Hi there, Turgeon here, bringing you physics from afar. Remember, this is more about you. Work hard. Let's do this. Number 24, session 2. This is all about convection conduction. Conduction is when there's transfer by touching. So the water is touching the aluminum. Then after that, it's a fluid. So the answer is B. Number 25, they need to have the same momentum. If they're going to have the same momentum, mv is going to be equal to mv. So the answer is going to be C because we need cart Y to be going faster than cart X, and it's half the mass, so it's going to have twice the speed. 26. We're talking about bending light, people. That's all about refraction. The answer is D. 27. Longitudinal classical example of sound. Answer is D. Number 28. Another classic. This time you're calculating the acceleration. Equation sheet. Right there. Put the numbers in. Answer is going to be 15 divided by 6. I think that's 2.5. Number 29 is kind of funny. You just got to read it, basically. The answer choice has to do with creating an electric current. And then the electric current creates a magnetic field. Okay, answer choice A. Number 30. This one's a little tricky. Let's find the change in velocity using this equation sheet. Put the numbers in. Acceleration, time, multiply both sides by 10. The change in velocity is negative 700. Then you do 11,200 minus that, and you get the answer choice B. Number 31. The total energy is going to remain the same. So the answer is D. Why? Because the elastic potential energy is going to become potential energy, which is then going to become all kinetic energy, so the total energy remains the same. 32. First part, don't be confused by the triangle H right out of the equation sheet. Don't be confused by the triangle H. It's just 15. It's just the height compared to 0. There's a potential energy. As she falls, kinetic increases, potential decreases. What could we do to increase that? Well, we want to increase the potential energy of the boy, so you increase the height of the girl. 33. Work is force times distance. Just take the force, multiply by the distance. The time is irrelevant. Look at these two. W and X are the same. 40 joules, 40 joules. 10 times 4, 5 times 8. Work is force times distance. Number 34. There's a classic V equals lambda F. Lambda is wavelength. It says that on the equation sheet. So do the math. Answer choice ends up being choice C. Divide both sides by 262. This number 35 is really tricky. Equation sheet. There it is. Now let's put the numbers in, but let's not worry too much about what the G even is. If you plug all the numbers in for a mass, and distance, mass, distance, mass, distance. 3 times 4 divided by 1 is 12. 5 times 6 divided by 4 is 7.5. 7 times 8 divided by 9 is 6.2. 8 times 10 divided by 16 is 1.28. So, actually, I might have divided by 64 accidentally, but it doesn't matter. The answer choice ends up being A because 12 is the biggest number. Doesn't even matter what G is. Number 36, you got to read, and there's also something we know for a fact. Sound goes faster through solids. I mean, look at the numbers. Number 37, the net force is looking at all the forces. It's not always good to think of it as a sum because sometimes you subtract. So we need a number that this minus this gets us the net force of 20. So 60 minus 40 gets us a net force of 20. So the answer is 60. This one's really tricky. There's a mathematical way to do this, but here's what they want you to think. Let's map out the temperatures, 20, 30, 40, 50. There's the 100 gram, there's a 50 gram. Well, there's got to be a temperature somewhere in between, but it can't be right in the middle because this one is more massive and hard to change. So the answer is going to be 30, not 35. My time was up. Look for the next video for the rest.